I'm Colin Waller, presenting my observed effects that acute daytime ocular blue light therapy has on working memory. Before I begin, I'd like to introduce myself. I'm a Tunstall High School student with a prospective education in computer science at Roanoke College. Due to the prevalence of blue light in screens in computer science and information technology, I was intrigued by the effects that blue light had on different physiological processes. After that, I learned of blue light therapy, a recent development and trend in the fields with merit in several medical applications. While investigating the current state of blue light therapy, I found that different medical fields have studied and focused on varying methods that blue light respects their respective areas, such as psychological fields finding improvements in seasonal depression and alertness, and dermal care engineers developing several forms of skincare routines utilizing blue light. More specifically, ocular therapy yielded psychological and physiological changes, and dermal applications yield physical changes. Therapy vehicles include light wands, light boxes, and overhead illuminators, as shown here. Extended ocular and dermal therapy require protective eyewear, but acute therapies under 30 minutes are safe from a distance. Furthermore, the duration and time of day in which blue light therapy is conducted directly influences the results of the treatments. For example, in the mornings, if blue light therapy is conducted, it aligns with the body's pre-existing circadian rhythms and increases alertness. But in evenings, it increases sleepiness as it inhibits melatonin to levels that are adequate to induce rest. In acute sessions, therapies inhibit melatonin in only approximately 3 minutes, but in longer therapies, between 1 to 3 hours, it is required in dermal studies and only benefits mood and ocular studies. Melatonin and its circadian rhythms are widely considered to be the primary pathways by which blue light therapy affects the bodies. Blue light excites receptors in the eyes, which typically observe ambient solar light levels to control melatonin production, leading the brain and endocrine system to regulate melatonin as if it were peak daylight hours. Improper light exposure will alter the circadian rhythm and cause a melatonin disruption. This disruption, called asynchrony, mostly affects the body at night when rest is inhibited, and bodily functions requiring sleep cannot wholly and properly work and cascade into a multitude of other problems. The most intrusive forms of asynchrony include jet lag, which is travel over several time zones when the body expects darkness and rest during daylight hours, and late shift working is forcing peak energy hours to be at night directly conflicts with the body's natural schedule. The variable of interest in my study is working memory, the rapid memorization and utilization of terms and concepts. Working memory directly connects the short-term memory processes with memory updating, meaning information processing, especially in language comprehension and in reasoning. The 3-step process for working memory is updating, task switching, and inhibition. Working memory is suggested to be the primary influence in both reading comprehension due to the morphological and phonological processing required. Additionally, no study attempted to find a correlation using working memory with both acute and daytime blue light therapy with melatonin regulation as the study's focus. Therefore, I justify my research through a gap presented in the field, which has excluded acute daytime ocular blue light therapy with working memory processes via melatonin regulation. The beginning of my investigation was the consideration and formation of my research question: how does acute daytime ocular blue light therapy affect working memory? To test the efficacy of my research question, my results will be compared to my null hypothesis, which states that if participants receive blue light therapy, then no observable difference in working memory will be observed, and my research hypothesis, which states that if participants receive blue light therapy, then an increase in working memory will be observed. I selected my hypotheses on the basis that blue light therapy at night was shown to increase alertness due to its inhibition of melatonin, which was correlated with an increase in working memory. When creating my methods, I gathered the study variables into their respective areas to isolate them from each other and improve data security. These include my independent and control variables, the blue and white light therapies respectively, my constants such as the location, illuminator, durations, and tests, and the dependent variable, the recalled words. To begin conducting my experiment, I first had to gather consent from my participants and their guardians, my supervisors Dr. Jones and Ms. Bowman, and my advisor for her use of the location, the Tunstall High School Library. Following the finalization of the necessary consent, I gathered the required materials for my experiment, primarily consisting of the Omega PDT light therapy illuminator and a randomly generated word list from a medical NBAC test site. Each day, I would prepare the area with a couch and 2 chairs for the testing and study areas. The participants were required to log their entry and exit times. Each experimental period was split into 2 sections, one each for the control and experimental data. The control period was chosen first as it had to eliminate crossover bias. This began with a 5-minute study period of the given word list, as seen at the top left, followed by a 10-minute illumination period with a white hue, as seen at the top right. Following the light immersion, participants would complete a quick memory test to remember all recalled words from the study period, as imaged at the bottom. Following the test, 3 minutes were provided as a rest period. The blue light followed an identical methodology, except that blue light was used for immersion and a second word list was given. Participants were allowed to misspell a word within reason, given that it was not another word. It could also study and write the words in any order. Upon the completion of the experimental period, participants would receive a written debrief form provided like in the photo and write for its collection. Then, raw data was compiled into a table and statistical analysis was conducted to measure data significance. For my statistical analysis, I used Data Classroom to analyze and graph my data. This graph shows the comparison between each treatment and the recalled words, with the white and blue data being colored respectively. The score of the recalled words ranged from 0 to 15. Displayed left of each treatment's data points are the sample mean as the center dot, with the 95% confidence interval stemming from it in both directions. This shows with 95% confidence where the true population mean, representing all high school students, would actually lie. The main cluster of white data lies between 10 and 15 recalled words, with only 3 of the values at a perfect score of 15. Conversely, the main blue data cluster lies between 13 and 15 recalled words, a much smaller spread of data, with 7 of the 15 values at a perfect score. The high perfect score count and the concentrated variance support the efficacy of blue light treatment, as there's 1/3 the spread and a much higher average scoring across all data measurements. Furthermore, the white treatment contained 4 low outliers between 6 and 8 recalled words, as opposed to 2 low outliers at 9 and 11 recalled words in the white treatment's data. This suggests that even the lowest outliers for the blue treatment are still higher and more concentrated than the white treatment, and supports the efficacy of the blue treatment. However, despite the lessened spread in the blue treatment's data, a statistical test still had to be performed to ensure that there was an actual difference between the 2 groups. Following my data collection and organization, I chose to use a t-test for the 2 sample means from the same population measured with different treatments. The analysis revealed a p-score of less than 0.01, meaning that there is an extremely strong confidence that the groups are statistically different. At a level of significance of 0.05, I reject my null hypothesis and conclude that blue light therapy does have an observable increase in working memory. My results support the application, at least temporarily, of blue light therapy as a treatment for struggling students with short-term memory and academic processes, especially considering that my sources suggest that melatonin is inhibited in less time than my study was conducted over. My participants were adolescents, alongside many of my sources which use them to measure either blue light therapy or working memory. Concentrated blue light from screens shows an increase in alertness, but the consideration of the role of dopamine or other sensory factors was beyond the scope of the study. This raises concerns about how the sleep patterns of adolescents with increasing sleep time are being affected and what consequences will follow developmentally over the next few decades. My study contains several limitations that may have affected the efficacy of the treatment or my conclusion. My sample was a small size of 15, the minimum size needed to conduct hypothesis testing over both groups. Additionally, my sample technique was a convenient sample, meaning that my peers were chosen by hand rather than randomly selected. A larger random sample would rectify this issue and improve the data stability. The schedule of my experiment was originally planned to span over 2 weeks, but due to weather and other unforeseen circumstances, instead spanned over 2 months at the convenience of the participants. While the times that the experiment were conducted were approximately the same, weather and other applications may have caused this to be a big limitation. A more controlled environment with a strict time and schedule that has participants pick their schedule beforehand may rectify this issue and caused by this limitation. My methods also presented other difficulties in measuring the exact increase in working memory. If the word lists were higher than 15 at say 50, there likely would have been no perfect scores and a more average increase in working memory per participant and treatment could be observed. My limitations in literature have presented new gaps that future research could seek to fill. Namely, with more comprehensive, difficult, varying, or numerous tasks, if blue light therapy will maintain its efficacy as observed in my treatment, and if sensory factors of excitement or boredom play a significant role in the treatment. Another factor that may hold a difference is the age range that receives the treatment and how effective that treatment will remain as the body ages, with the slowing of the circadian rhythm and worsening eyesight. An additional point of interest would be with inverse effects with red light therapy could be observed, as red light therapy was shown to block out the effects of blue light therapy in relaxed users. This also raises the concern of whether relaxation or alertness is more beneficial and efficient for working memory processes to be studied. My experiment and the research process have developed me into a far better scholar and have notably taught me the values of resilience and grit, that no matter what challenges presented, I always have an opportunity to persevere and that giving up is not an option. Moreover, I've learned that discipline leads me through my challenges. Sometimes, when without motivation, the only source of power that I can rely on to keep me going is discipline, so that habits that I form will make or break my success for the rest of my life. And forming my experiment showed by committing to my task with devotion that I can accomplish anything I set my mind to. Knowing this, I feel more prepared for my future education and to seek out each of my aspirations and working for a better future. A special set of thanks to the participants for enabling me to collect my data and conduct my experiment, my research teacher, Ms. Long, for all of her help in guiding and correcting me over the past 2 years, and finally Mrs. Yates for allowing me to hold my experiment at Tunstall High School. Thank you for listening, and do you have any questions? Mr. Talarico.
So, if I understand this correctly, there's a 5-minute study period, they got the light, did the recall test, and then after the 3-minute rest period, was there another set of words that was given to them?
Mr. Talarico asked if there was another set of words given after the study period. Yes, my methodology had a 5-minute study period, a 10-minute illumination, and then however long it took them to write the test down, a 3-minute rest, and then we repeated it with a different word list and a different color.
So my follow-up question to that is, I guess, how did you determine that the 2 word lists had the same difficulty?
Mr. Talarico asked, how did I determine that the 2 word lists have the same difficulty? I divided each of my word lists into different word lengths, so from 3 to 6 letters, 6 to 9, and above 9. And I would make sure that there was an equal amount, or as close as I could get to equal for each word length.
Thank you.
Thank you.
Good job. Did you see any words, any similarities in words that they missed or they used that they remembered between the participants?
Ms. Collins asked if I noticed any trends between the differences in missed words or collected words. I didn't observe any noticeable trends within them. One mistake that did happen is one of my words was relation, and a common occurrence was that people would write relationship or relation, something else that extends beyond it than just the word relation, and I couldn't count that. Any pluralities were also counted as wrong because it was technically a different word, so that was a common occurrence that would happen.
So are you taking a blue light with you to Roanoke College?
Ms. Collins asked if I'm taking it with me, my blue light with me to Roanoke. I'm not planning to, but I hope that maybe if I ever get in a struggling situation, I can use it.
Go Maroons.